Jó estét kívánok mindenkinek! Nagyon örülök, hogy elfogadták a meghívásunkat, és részt vettek az okos jövő innovációs klaszter klubestjén, és hogyha nem gerjedünk, akkor még jobb lesz. A rendhagyó klubest, ilyet még nem csináltunk, a technikát a kollégák köszönöm szépen, nagyon ügyesen összerakták. Podcast lesz belőle, YouTube csatornán is ki fogjuk tenni. Biztos ismeritek egyébként, oda ki is raktuk az asztalra, hogy már van YouTube csatornánk, ahol már 4 tartalom már fönn kéne, hogy legyen. Ez lesz az 5., úgyhogy ott vissza is tudjátok nézni a mai estet. Ez az egyik, a másik pedig, hogy rendhagyó abból a szempontból is, hogy ugye a brit nagykövetségnek köszönhetően, Focis Krisztinek köszönhetően brit szakértőkkel fogunk beszélgetni, illetve 2 magyar szakértővel fogunk beszélgetni, alapvetően flexibilitásról, villamos energiarendszerben a flexibilitásról. Úgyhogy köszönöm szépen, hogy eljöttetek és elfogadtátok a meghívást. A harmadik különlegesség pedig az, hogy angolul lesz a vendégekre tekintettel a beszélgetés. So, good evening, ladies and gentlemen. I'm just asking the colleagues in the UK, can you hear me?
Yep, no problem.
Okay, thank you. So, good evening, everybody. This is let's say the evening of the Smart Future Innovation Cluster. This is a kind of usual happenings. We organize several times in a year, and this time we selected a particular topic to be discussed between the colleagues from the UK and the experts from Hungary, that is the grid flexibility. This is a kind of a discussion. I kindly ask also the audience that if they have any question, then do not hesitate to raise this question either to the Hungarian experts or the experts from the UK. I think that we should start with the introduction. I ask all the colleagues, let's say that starting with the UK colleagues, to introduce themselves. Please, Gordon, if you don't mind to ask.
Hi, so I'm Gordon Russian. I work in our I work for LCP Delta, which I think Lawrence might introduce a bit more broadly, but I work on both our consultancy team and our flexibility research service, which kind of maps regulations and requirements across the whole of Europe for accessibility and entry into different flexibility markets in each country. Yeah. Lawrence?
Okay. Yeah. Thanks, Gordon. Yeah, so I'm Laurence Robinson, LCP Delta. I'm a senior consultant here focused on flexibility markets and the emerging space in flexibility across LCP Delta. We're an energy consultancy. We're mission driven, focused on all aspects of the energy transition and supporting businesses and governments around Europe on exactly what's needed in order to transition our energy systems to meet the net zero targets that many countries have across Europe for around 2050. We have several different services. A big core part of it is based on data-driven research, where Gordon was mentioning. We have a specific team focused on flexibility, but we also focus a wide range of areas from EVs, heat, energy networks. We sit in a consultancy group and we do bespoke projects for our clients, and we're always trying to understand the latest technologies and innovations that are happening across the space. So I'm very pleased to be here and to speak to you about grid flexibility.
Okay, thank you. István.
Good evening, everyone. My name is István Vokony. I'm an associate professor at Budapest University of Technology and Economics at the Department of Electric Power Engineering. Basically, what should I say, in the last couple of years, it was a pleasure and honor to participate in some Horizon 2020 and Horizon Europe projects, for example, Flexitranstore, Interface or OneNet, which all covered some kind of environment or market model for involving and enhancing the flexibility itself. Generally, my main research area is connected to the grid stability and renewable integration, and of course, I do have a serious opinion about that, but I'm very open for hearing the opinion of the UK colleagues and on the audiences that flexibility can be a solution for the stability and reliability questions, or it's a little bit different thing.
Thank you, Peter.
Good evening, everyone. My name is Péter Sőrés, and I'm representing here the Budapest University of Technology and Economics, where I am assistant lecturer at the same department where István is. And I'm also a head of department at the local utility, MVM. My main research area is centered around the electricity markets, from the energy market, the scheduled energy markets, to balancing markets, and also to flexibility markets as well. I have been participating in various Horizon 2020 projects through the university, and this is my main research area.
Okay, thank you for the introduction. I suggest that we can just jump into the middle. But first of all, I ask some of you to, let's say, define what we are talking about. So what do we mean by grid flexibility? What is it, and why does it matter at all that it worth to organize such an event as well? Anybody who would like to, who is brave enough to start defining the topic?
Really good to jump out how not to answer for the question. Before we started, I just cross-checked by Google, is there a specific definition for grid flexibility at all? Because, yeah, we already know the Clean Energy Package initiative, what the new challenges are coming into the foreground, and so on and so on. The first result was on my phone is to enhance the market participant, come closer to the energy market via flexibility. But no answer for the definition itself. So later on, I tried to find a general definition for that. And yeah, I do have my own definition, but it was various that which entity defined the phenomenon. So if a DSO made the definition, they do their own purposes, how to interpret the solution. And from the other hand, from the regulator point of view, they would like to broaden the possibilities via the flexibility, but how to make it from practical point of view and implementation, or the market mechanism. If it's only about market mechanisms, no real solution for that. But of course, I should answer something. And from a strict point of view, we could say, in my understanding, that flexibility could enhance many other market participants to go, for example, ancillary services, or for such kind of market possibilities on the energy market, which was not possible previously because of volume problems, or any other physical or economical problems, or probably legal. But from the other side, I'm more than sure that it is not only about a market definition and the market mechanism, but much more, not only taking a solution for the I don't know, reactive power problems or voltage problems for a DSO, for example, or congestion management, but it can mean much more than energy or capacity only.
Maybe if I may add that we have a electricity market that is defined on the scheduled energy deliveries, with strict timings and very defined set of power capability power profiles. So any additional derivatives of this product can be defined as a flexibility. Of course, some of these flexibility defined with this derivative is not really applicable for grid flexibility, but the derivatives that has some temporal and locational specialties and very defined set of characteristics that could be useful. That could be a useful flexibility for the grid itself.
Gordon?
Yeah, I guess I could kind of go for an even more basic definition, where essentially flexibility is just a change in either the consumption or generation from a customer from what they would have originally been doing. I guess that becomes very technical and very complicated, trying to define what someone would originally have been doing, and there's plenty of papers out there and a lot of research trying to figure out the best way of doing this. And we probably don't have enough time to really go into this in much detail. But yeah, I guess from our research, there's kind of two specific types of flexibility. There's one that's implicit, which is essentially the customer would change their consumption based on energy or monetary savings that they can make. So this would be changing your consumption based on a time of use tariff, and then there's a second one, which I think we're more interested in for this conversation, which is explicit flexibility, which is more around generating revenue through a flexibility market or providing a service through to one of either the DSO or the TSO.
Lawrence, anything to add?
No, I think that's perfectly explained by everybody here. I think just the degree of flexibility in terms of your ability to change your position close to the time of delivery. I think that's the way that I see it. If you're changing your delivery on or at delivery, then you have a high degree of flexibility. But the more warning you need, the lower flexibility you have, and that changes the value of the service you're offering. But that's the main elements of covered. Thanks.
Okay, just another question about the background. So why do we need this kind of flexibility? So what are the basic drivers? Why we are talking about this today? What are the challenges?
I guess I can start as well then. I guess everyone's aware that the energy network, the networks are changing and how people are using the networks is changing. In the past, we had very large centralized generation plants that would feed down from top down, essentially transmission network down to the customer at the low voltage network. And now this is getting much more complicated, that there's generation and distributed generation at every single level. So we're having a lot of difficulties with managing that changes of flow of energy. And then there's a second part on top of this, that the demand consumption is changing. So this move towards electric heating and especially electric transport and electric vehicles is changing the way customers, firstly the volume of electricity that customers are needing, but it's also changing how they're using it and at what times they're using it. And this brings a lot of difficulties to the network operators just in terms of meeting peak demand, but it's also in basically they have less visibility of what people will be doing and when. So flexibility is needed to help manage this change in basically manage how the networks are changing and how the customers' demands are changing.
I think I would add to that all networks have had flexibility because there's a need always to match supply and demand perfectly. Obviously, they have to perfectly match on delivery, and most networks have been demand driven, so supply is always flexed in order to meet demand as it's changing over time. But with the change of generation to particularly solar in Hungary, but wind in other countries in particular, we're now becoming more supply driven in terms of our energy markets. And we're having to flex other assets and demand in order to manage around the supply, which is intermittent. But also, as Gordon mentioned, we're needing flexibility in different parts of the network, where historically it's all been within the transmission network and able to manage the overall supply. We're needing to embed more flexibility within the whole network, which is a significant challenge and more complex than the current approach.
Can we a little bit elaborate on the level of the voltage level of the whole energy system? Which one is affected by these new type of behaviors, either from the loads, from the demand, or from the production?
Yeah, sure, of course. If I may connect to Gordon's opinion, that the basic problem is that, I'm a little bit rude, but we're getting lazy. So we used to that in the last, 5-6 decades, everything was absolutely fine. It's obvious if I turn the light on, it will be okay. So we have I don't know how many 4 or 9 nines reliability of the consumption and the generation, and we used to that huge power plants, transmission lines, everything else working properly, and only one direction is how the energy transmitted, distributed, and consumed. I had a chit chat with one of my colleagues at the university. He's from Vietnam, and he absolutely openly asked me that, is it always available for you? Because we struggling with that for days, for long hours. There is no electricity because many of the customers wanted to put a solar panel on the rooftop, and the network was not prepared for that. So answering your question, not the problem, the issue begins at the low voltage level from the beginning, I guess, but it will be quite fast reach the medium and the high voltage levels as well, and not definitely only on a linear way. So yeah, from the beginning on the rooftops or small solar power plants and everything else, and the whole setup and the probably the rules of the stakeholders will be changed. And yeah, we can argue about that. For example, on a 120 kV connection, the solar panel is the problem of the DSO or the problem of the TSO, but we are still working, living in the same synchronized electric network. So yeah, probably the first and the second issue will came up on the low and middle voltage, but very suddenly it will be available on the high voltage to do something.
It's interesting to see that we have identified that we need more from the grid. So we have more supply bottlenecks, we have more demand bottlenecks. But the main question here is why we are not planning to do with the what can we do with the traditional investment methods. So for example, in the 70s or 80s, the obvious answer was to capex this problem out. So we would invest in more grid, we would invest in more transmission stations and so on. So the main question here, why we are not able to follow this strategy of network development. And I think I may have some answer for that, for maybe 4 or 3 decades, the demand for electricity stagnated. So we have a plateau, at least in Hungary, from the 70s to maybe the early 2000s. We have the plateau for electricity demand. So we are not used to invest in such a huge amount of new network grid elements. So we are not used to invest in. We do not have the right capabilities to do this. So this is partly because of the technical capabilities and partly because of the financing. So it's not really obvious to speed up the network development to have a traditional approach to solve these new requirement problems.
Sorry, Peter, just one more additional idea. I think that not the solution is the flexibility itself. It can be one part, one technique, one something in the complex picture, but the energy storage, I should say a lot of IoT, a lot of things, but a complex solution has to be found somehow, and a mindset change is needed for that. And yeah, it sounds like a bullshit thing, but as we used to in the last 30, 40 years, how to prepare, how to plan, how to operate the whole network, it has to be changed because the whole environment, the behavior of the end customers, the technology, the available technology, and the regulation has changed, and therefore we had to react somehow. And not to, if we would like to react using the old fixations, why are we expecting different result? It won't happen.
Okay, so here in Hungary, if I may sum up, so the type of challenges, or at least the voltage level of the challenges, are low voltage and middle voltage, and later on, just because of the whole system is interconnected, then of course these challenges are migrating to the high voltage and even to the system operation. On one hand, on the other hand, Peter just said that the old answers are not applicable anymore because we are not used to develop the network in such an amount which would be needed today in order to cope with these challenges. What is the situation over in the UK?
I think, yeah, it's very similar in the UK in that we are faced with the challenge of massively increasing the size of our network to address actually a very largely expanding electricity network forecast in the UK. We, I think, forecast a doubling of our electricity network in terms of the overall size of the energy going around it over the next 10, 20 years. And if we did that, like you say, the traditional way, it would just cost tens and tens of billions of pounds. So it's not flexibility is the only solution. It's that a more complex, smart solution should have a lower overall cost, is the theory of our distribution operators in the UK. And they're bringing out their approach is actually flexibility first. So how much can they exploit flexibility to minimize the capex cost or optimize the capex costs within the network structure? But also you have to bring in other criteria, not just cost. While lowest cost is ultimately the aim, resiliency of the network is important. Like you mentioned, Esteban, we've got this expectation of 99999 reliability, and that's very much still the case. So building these smart networks in the future that maintain that reliability with the new infrastructure, with the EVs, the heat pumps, and managing increasing storms we're having in the UK as well, and how those things all have to become integrated together within a future network. And flexibility is absolutely core to that in bringing that kind of cost optimized solution. And that's the approach in the UK that's being taken at the moment.
Okay, so let's go into the details that what sort of challenges are we talking about? I've heard voltage problems, load flow problems, congestion. What are these? Why are they? Why? What was the situation before all these huge amount of distributed energy production? Prosumers are getting into the picture. I guess that voltage was in place before that. There were load flows as well. There might have been some congestion as well on the distribution level as well. So why are these now? These problems are really such a huge problem. So what kind of technical challenges are we talking about exactly, and why are they so important today?
So if I may do the first bet, I would state three things. One really important change is that there are a lot of generation amounts which is not measured. So we do not have the information what is happening on the low voltage level. A huge amount of PV solar solution on the rooftops and other aspects. And yeah, we have some information about the total or year consumption, but not online or real data about that. Second, it is weather dependent, and yeah, if sun is shining in Hungary, in all household will it be a generation amount, and it's really difficult to forecast, and the problem will come into the foreground quite fast. I had a negotiation with a transmission system operator colleague, and he told me that in a really nice sunny April afternoon, 1,400, 1,500 megawatt is the volatility if there is some cloudy weather in the afternoon. The total consumption in Hungary is 6,000, so quite significant. And the third one is that the operation of the network was one direction, and right now there is in some cases such kind of generation that not only on the low voltage, but from the low voltage to the middle voltage, some different angle or different generation direction came into the foreground. So at least these three aspects generating technical and economical challenges.
And we are still in the domain of steady state voltage and steady state flows. So we are not yet fully apprehend the dynamic environment and the transient features of this grid. So it's additional interesting phenomena that should be dealt with. But right now, our distribution operators, network operators, are called as system operators, at least in the Hungarian language, but technically they are network operators, at least for the medium and low voltage levels. So for the high voltage grid, they are truly system operators, so they have online metering and monitoring systems, system for the high voltage network, but for the medium and low voltage, it's not yet fully digitalized, so we do not have the full information what is going on the grid. So of course there are some issues and problems with the voltage, but not yet a full understanding what is going on right now with our grid. So this is the main issue here, and we are still only starting to understand the steady state problems of this grid. And with the lots of inverters and other new technical part of the grid, it's going to be more interesting in the future.
Okay. Any reaction from your side?
I think that largely covers our understanding of it as well, that there is just, in the past, there was less of a need for visibility of the demand side customer because they were more predictable in how they were using the network. But now it's more important for the DSOs to know this, and we should say as well that we're asking the DSOs to change quite quickly. It's been in the last 10 years or so, which isn't a very long time in terms of these large types of operators, but it's a type of change that is needing to happen quite quickly. I would also add on one thing, that these networks are quite old now as well, that across all of Europe these networks were built, I don't know, in the UK it was 60s, 70s was a real big build out in the networks. And while we are still building out and renovating it, it's a lot of this electricity is going through infrastructure that's 40 or 50 years old. So while it was potentially optimized for a certain use back then, it's now being asked to do a different operational use, and it's also not in peak condition. So this brings added extra issues into this equation.
Okay, so we discussed the root cause of these new challenges, the challenges themselves. Let's talk about the possible solutions for that. So we have heard that, let's say that network development is no longer the answer, the only answer, and these market-based solutions might be part of the answer, which also can, let's say, save some cost as well. So what is, or what should be, what could be the answer for these challenges? I guess flexibility. Just a hint. So what are the answers?
Of course, it's flexibility. The main question is how we can activate this flexibility, how we can communicate, how we can allocate the flexibility. So flexibility is always there. So if we have over voltage problem, then maybe the inverter would go off. So it's some kind of flexibility. So we have protections and automations in the system. So it's already flexible enough to save itself from collapsing. So this is one very basic flexibility we are currently dealing with. Of course, the actively managed flexibility is the key here. Since 2019, we have the legal possibility for the DSOs to participate in these services and require these services from the flexibility service providers. So there is a possibility, a legal possibility, but right now we do not really have all of the understanding how we can integrate this possibility into the operation and of course the strategy of these system operators. So right now we have some pilot or even more advanced projects to include them into the DSO operational planning and long-term planning as well. But this is the first step. So if we have some technical solution to do this and actively manage the flexibility, then the other part is needed here to include them in the workflows and the business processes. This is the key challenge ahead of us. I can say that we have the technical solutions, software solutions, and the algorithms, and the understanding how the managed flexibility could work with our existing grids. But the key challenge here is to include them in the workload and in the workflows of the operators.
So in essence, we know how to solve the situation, but there is no implemented solution in place in Hungary today.
There's ongoing projects to implement this, but not yet an active solution for.
Okay, what's the situation in the UK? Because we heard some rumors that there are already in place solutions in a couple of regions or several DSOs in the UK.
Well, I'll let Gordon take the specific DSO challenge. I mean, I think in a question, but for UK, there's been a lot of work on flexibility markets from a national point of view, and trying to identify where we can access more flexibility, and demand side flexibility is a key target for our regulators, the ESO, in how we enable, whether it's commercial, industrial, or domestic flexibility to provide that service to the network. They're seen as a theoretically low cost and net zero approach to flexibility. However, we found, over the years, it's quite challenging to build systems that enable this to work at large scale and remove the barriers to entry. Even in the UK, we're having challenges with building the markets. We've been probably some of the most progressed in Europe in developing these markets, but getting the governance right, getting the data flows correct and transparency for all the market players to essentially allow people to enter the market, allow organizations to enter the market, is challenging. And underpinning all of this is really critical is that digital infrastructure. Like you said, the software and the approaches and standardization to share data is a big focus in the UK. The regulator here is trying to bring together the DSOs, the ESO, also thinking about regional planning and the network as well, and how these things all interlink together. No longer can they be siloed separately. In order to build the system, they need to be bring together under a common approach and common digital technologies for the kind of 21st century. So definitely a big solution is getting that more flexibility in, but it isn't straightforward, is our experience, because it's relatively novel and the scale of it is actually quite large, because you're not talking about one big power station, you're talking about lots and lots of players when you're looking at this distributed flexibility systems, which has quite a different approach needed. Where we have had big steps in the UK is big batteries. You might be aware that the UK is one of the largest rollouts of the kind of large scale grid flexibility batteries. I think we're up to 2 gigawatts on plus of big batteries in the UK now, and there's 5, 10, 20 gigawatts in the pipeline in the UK. Huge batteries on the grid solving the big problems, but then those aren't addressing these distribution problems at the low and medium voltage levels, where there are new markets being developed. I don't know, Gordon, I can hand over to you on some of the DSO flexibility markets and the current status of those in the UK.
So as of this year, all 6 of the DSO or DNOs in GB have had at least one procurement of DSO or flexibility through their through this ENA system or the PICLO market platform. And yeah, it's kind of come through this quite large association called the Energy Networks Association, which is a collaboration between all the different DSOs and gas DSOs in the UK to develop these flexibility markets and work together to enhance the flexibility that's available to these in these markets. And some of the key things around this is ensuring as much transparency as possible is one of the first points, and then make it as simple as possible for everyone to participate. So there creating or trying to reduce as many barriers to entering these markets and providing these flexibility as possible. But yeah, as Lawrence was saying, there's still quite limited value to be gained from DSO flexibility in the UK, because while we are aware that it will be a big issue in the future, the rollout of EVs and the rollout of electric heating isn't having a significant impact on our networks to the extent that it's costing them a huge amount of money yet. So currently these markets are being made in advance to prepare themselves for when they will be needed in the future. And that's when we'll see the value of these markets increase, we expect. So at the moment, while we have these huge battery projects coming online, they're not coming online to provide DSO flexibility. It's more to do with the TSO markets. But as these markets become saturated, we're likely to see potentially more value if you're in the right areas where these congestions are happening.
What you asked for the solution. In my opinion, the flexibility is the duct tape of the energy industry. So it's on time perspective, it's a quite fast and quite effective answer. But as Gordon mentioned, there are many assets as well in Hungary, which was prepared and installed in the 1930s or the 1940s. With the flexibility, it won't survive 50 more years. So we can save some time with that kind of solution, but during that time, we can prepare how to plan the future network, and to do that, not only to plan, but implement it. So from one side, in my understanding, flexibility can be an effective element to prepare and to do the mindset change. And yeah, of course, many other aspects has to follow that. But on the other hand, if we are talking about ancillary services, energy market, if we are talking about flexibility market, inertia market, capacity market, doesn't matter. At the end of the day, it is about the capability of producing energy or the energy itself. So as I'm coming from the academia, nothing is too expensive for me. A universal market can be a solution somehow to find and collaborate the different market participants to do the same activity, generate energy or put the capability into the market for generating energy. And doesn't matter what kind of usage is it, go for an aggregator, for a transmission system operator, for a distribution system operator, for anyone, doesn't matter. At the end, someone has to produce and someone has to pay for the energy.
Right. I'm not saying that I'm out of the questions. I mean, I could really raise some other questions as well, but we have an audience here. So if anybody has any question considering the topics, or you guys in the UK, if you have any specific question considering the Hungarian flexibility market or future flexibility market, just go ahead.
Is there any modeling tools for the network flexibility in UK? At first, I'd like to ask you to let us know if you have any. And the second question, what will be the impact of the rising EV charging in most countries or in most networks?
Can you repeat the question? Sorry, it's hard to
hear.
The
first question was, do you have any modeling of the flexibility market in the UK in place?
I guess the question is, what do you mean by modeling? I mean, there's a lot of modeling that happens on all markets across the UK.
I guess that the flexibility market modeling, this is a small scale implementation of the live market, where you can really test the outcome of the market rules, you can simulate the possible behavior of the market participants, and so on.
Well, we conduct this in LCP Delta as a big market model. We have a big stochastic dispatch model that has every power plant in the UK and operates them all and tries to understand how they will operate with different prices, different inputs, and is used by a wide range of companies, including our national grid and the UK government. So yeah, it's quite routinely done to test different scenarios about what the future of the energy system might look like and look at, in particular, constraints on the network. We have a big constraint in the UK between Scotland and England, and there's a lot of wind power in Scotland and a lot of power needed in England. And this is a big challenge for us in terms of curtailment of renewable energy and the challenge on the grid and how much you can need to upgrade the network and to manage that, and how much you can deal with that from a flexibility point of view. So we have similar but different issues here that are modelled quite continuously in the UK. Yeah.
Okay, great. The other question was what could be or will be the effect of the ever-growing EV charging?
Yeah, I think originally we were probably more worried about EV charging at the beginning because there was an implication that it would have a big increase in peak demand or potentially peak demand and therefore a big impact on the network. However, actually, unlike heating, which electric heating, needs to be pretty much on when it's cold and you have limited flexibility, EVs are actually relatively flexible in terms of when they charge, not even within a day, but within a week. And so I think it's likely there'll be sufficient approaches to incentivize charging at times which are most beneficial to the network. First of all, there's an approach that chargers by default only charge from kind of midnight in the UK, and I think this is similar in Europe, so that most of the charging is happening at night time in any case. And then tariffs coming in which will automatically charge the vehicles at times when it's cheapest from the network. In addition to that, obviously EVs can potentially even provide some of those ancillary services in practice. That's challenging, but definitely possible. And there's a lot of work going on about how you can optimize market rules to enable, these kind of vehicles to participate in those markets. So EVs are challenged. There's a lot more energy needed in the grid. We ultimately need to build lots more power stations in order to provide that energy, whether that's solar, whether that's renewables, wind, whether that's nuclear. We need a lot more energy, but at least vehicles come in with flexibility kind of inherent within the way that they work.
What's the situation here in Hungary? Let's start with the system modeling.
As far as I know, the EV charging phenomenon in Hungary is still a disaster to the network. So the quite huge big demands and massive network investment needs and everything else. And a couple of months ago, I read an article about a startup in the States, and it was a taxi company or something like that. They bought a lot of electric cars, but only the second priority business case was to bring people from A point to B. The first priority was to provide ancillary services. So they grabbed together the 20 or 30 cars on the defined points, and they provided the possibility to discharge the cars, not only to charge, but discharge as well. And yeah, if there was no need, probably they picked up some people to travel them. So it's again a general thing. A technology can be a good or bad thing. We can utilize a technology on an appropriate way, or we can waste it. So let's think about 2 or 2.5 million electric cars on the Hungarian ways, which, I don't know, 50 or 70 kilowatt-hour capacity. And if somehow we can manage them to charge or discharge during the day, it's quite a huge power plant capacity. And with IoT and ICT solutions, it's still possible.
Regarding the e-mobility, we are already seeing the problems regarding the connectivity of the grouped and concentrated demand for e-mobility charges. For example, for a block of flats, a condominium, if it would like to sell the houses, the flats, it needs to offer some form of EV charging capability for the garage parking places. So, for example, for hundreds of flats, it needs quite a lot of connecting capability to the grid if it's not mitigated or solved by some form of smart charging or load management. So it's already happening in some places of the grid, for example, at the behind the meter areas where it can be aggregated. So the main question here, whether we have the network capability dealing with all of the charging need that is already regulated in the alternative fuel infrastructure directive or regulation defined by the EU to provide large capacity charging stations. That could be a challenge for our DSOs to provide hundreds of kilowatts of charging capability at remote locations through the TEN-T networks. So that could be a problem in a couple of years. Regarding the first question on flexibility modeling, I'm not really aware of any system-wide modeling that would include medium and low voltage. Of course, there are lots of transmission system models and development models for the high voltage network and ultra high voltage network, but not as an integrated long-term planning for medium and low voltage that would include the active flexibility providers as well. So that's a gap right now, at least in the Hungarian forecasting.
Okay, I see. Thank you. Any question? Any more? Yep, please.
That's like regulation options, so the context-based regulation, and another type of regulation which differ from the continental European ex-ante regulation. As well as I know. I don't know whether of these two main differences could speed up the usage of the flexibility by the DSOs or not, because formerly the option used the context-based regulation, but it was similar to the continental European regulation, but it has been changed some years ago. I don't know the exact answer, but the other type of difference is the ex-ante and the ex-post differences between the European countries and the UK, whether these would contribute to the usage of the flexibility by the DSO or not. These are the questions. Most of the colleagues from the UK.
Yeah. I'm not sure whether the colleagues from the UK could hear the question.
Sorry, not all of it. No.
No. Yeah, so, okay, it was about tariffication of Ofgem, of the regulator, how the tariffication was changed just recently in the last couple of years in the UK, so as to somehow force or promote the DSO to use flexibility. And I've heard that it was before that it was TOTEX based and ex ante, but now it has been. Yeah. Okay. Yeah. So Ofgem is we have an expert here on DSO tarification. So Ofgem is currently using TOTEX-based tariff system, while in Hungary or in Europe we have, let's say, OPEX or cost-based tarification. The main question is how the tarification was changed in the UK by the regulator and how it has contributed to the, let's say, the usage or the spread of the flexibility market from the DSOs.
I'm not 100% sure on how specifically it changed over the years, but essentially this TOTEX mechanism has meant that the DSOs in particular are incentivized to provide or to determine the optimized mix of capacity or capex costs and OPEX costs. So it's makes, so this kind of goes back, I guess, to the modelling question previously, that all the DSOs in the UK are required to model at each of the levels where flexibility will be needed and where reinforcement is needed. And this does drive a big push towards trying to reduce capital costs where possible, or where it is optimum for the customer, or optimal for the customers in the long run.
I just one additional question considering this topic. The question is very simple. Are the cost of flexibility paid by the DSOs are covered by the tariff? And in what sense, what extent, and how it is covered or not?
Ultimately, it is paid for by the tariff. I'm not 100% sure on how we're in. Sorry, you're muted, Lawrence.
Okay, what's the situation here in Hungary?
Actually, as far as I know, there's no incentive and no recognition of such OPEX costs. So what we have in Hungary, the flexibility market projects, that these are funded by some R&D grant and also some capex from the DSO itself. So it's still centered around some form of fixed return of investment. So it's still an investment, and right now it's not part of the operation and not part of the accounting of this OPEX cost. So the main focus right now is on optimizing the capex, the traditional network development costs, and there is no, as far as I know, there is no incentive and no recognition of various alternatives of capex and OPEX based solutions. So there's no mixing and optimization of this capex and OPEX based solutions. So the only constraining factor here is the time of needed for the grid development. So if there is no time for reinforcing the grid, then we only have the solution of applying some form of flexibility. But this should be a very integral part of the tariff mechanism, because we have a very different financing environment in contrast of a couple of years ago, where we have very low financing rates. So right now, the OPEX-based solutions should worth more for the regulator, that should aim for reducing the total supply cost.
What do you think the today's tariff structure is flexible enough to handle the new behavior of the prosumers, the new technologies, the new market mechanisms? So I guess you know my answer, but what is your opinion about that?
I think we have the solutions for that. So for the TSO, for the transmission system operator, we have plenty of cost recognized for the ancillary services. So we have the OPEX-based solution that is covered by the tariff. So it's not really a structure issue. So we have the solutions for that. We need some willing from the industry and for the stakeholders to go through that door and just copy what the TSO does. So it's quite simple, in my opinion. But I haven't seen any proposals for that.
Okay. Just one more question, if anybody has anything to ask. I just urge also you guys to raise questions if something important we are missing here.
Is there any regulatory pressure to use flexibility either in UK or international? What do you think?
Is there any regulatory pressure in the UK on the DSOs to use the flexibility market?
Yes, absolutely. They are, as part of the cost control of the network charging, how the networks are paid, they have to invest and build these flexibility markets as part of their planning. There's a cost control program that runs every 5 years in the UK for the DSOs, and they have to submit their business plans, as Scott was saying, in terms of modeling how their networks are going to be upgraded over those 5 years and the investment they need. And some of the money that they gain is in advance of that investment. So it's kind of forward planning, looking at the needs of the network over the next 5 years. And they have to build in flexibility into those to provide that cost optimized solution. So they are encouraged quite strongly to develop flexibility markets to optimize their solution for grid reinforcement.
I'd add on to that as well that we're talking, saying are they pressured into it might not be the right wording, in that essentially DSOs and DNOs we talk about they're incentivized to build out networks. In reality, they're incentivized to make money because they are private organizations. And the way that they're regulated in the UK means that they can make more money by potentially optimizing this, the way that they're spending through operational costs and capital costs.
So their revenue is limited by the regulator. They're kind of regulated in terms of the revenue you can get. So from them, their approach is to minimize costs. So that's a key element within the kind of operating profile of the private companies in the UK.
Okay. I guess that you, Peter, already answered this question in terms of the Hungarian situation.
Yeah, so there's a stark contrast that we see that there's not any pressure or incentivizing mechanism to use flexibility, but full disincentivizing mechanisms for using flexibility. So for CapEx, you have some rate of return, maybe it's low, but there is some positive return on the CapEx. But for any OpEx that occurs during the network operation, it is benchmarked and is controlled by static and dynamic means, so it's fully capped. And even if it could be integrated, from the next year into the recognized cost base, then it would be maybe 100% recognized. So there's no incentive to use this. And the main, maybe there is a point of view problem here. So we are right now speaking about the cost of this flexibility, but we do not assess the value of the flexibility and what is the leverage gained by the network operators, and what is the upside of using flexibility, what can be done with more integration of renewables and more and faster integration of new load and generation. That could be a new point of view that could be that could underline the importance of and the value of the flexibility.
Right. Okay. I think this is time to finish the discussion. I'd like to thank to the colleagues from the UK to join us and share their views about this particular topic. And I also thank you for the Hungarian experts to answer the questions and to share their views. I thank you for the audience to come up with very nice questions. And don't forget that you can re-enjoy this discussion on our YouTube channel. So please check out our YouTube channel of Smart Future Innovation Cluster. So thank you very much for participating, and have a nice evening, especially in here. Unfortunately, you are not here, guys, from the UK. Maybe we'll have a chance to meet in person, face to face, and then we can share more ideas and views about these topics or others. So thank you for coming and joining us.
Thank you very much for having us. Thank you for the questions. Thank you.
Thanks.